Select the major product of the following reaction. So in this reaction, we are starting with an alkene, and we are adding to that hydrobromic acid, and we have something else in there. We have peroxide. And so when you have hydrobromic acid, specifically, this only happens with HBr, and a peroxide, we end up getting a radical reaction. And so what this does to our addition of HBr is it kind of flip-flops the selectivity, and so we end up seeing the anti-Markovnikov addition product. So normal Markovnikov addition would have the hydrogen adding to the less substituted carbon and the bromine adding to the more substituted carbon. So the anti-Markovnikov product would do the opposite. It would put the hydrogen here and it would add the bromine to the end carbon. So that is option C. So in case you are wondering how this happens, just really quickly, remember we said previously that Markovnikov's rule really should be stated that the electrophile adds to less substituted carbon. So if you want the bromine to add to the less substituted carbon, bromine has to become the electrophile. And so under these conditions, it does. And the electrophile it becomes is a bromine radical. And so the bromine radical adds to this alkene first. So we're showing one electron from the alkene, kind of rendezvousing with that one electron of the bromine, and the other electron from that alkene goes to form a radical. And so this addition is done so that you form the most stable radical intermediate. And so this is exactly analogous to how we used to form the most stable carbocation intermediate. And so how this can gain a hydrogen is to react with HBr to continue this reaction sequence. So if you have HBr, the more stable radical is going to be the bromine, the larger atom. So this can react with the hydrogen. So we're forming a hydrogen-carbon bond here, and then we can form bromine radical. And so this can continue the reaction. So you form Br dot that can just keep going through the reaction cycle. Radical reactions are always like this. These are pretty reactive, so you keep the concentration low. So you see this, a small amount reacts, and then you get this key radical that can keep propagating the reaction.